Let's talk through one more example of a one sample t-test. And this one will be a little bit of a twist. Spoiler alert, it will not be statistically significant. So we'll see how we have to interpret and report our results when p is greater than 0.05. Does the average student at Tufts Medical have an IQ different from 100? This is a research question. How do you know it ends with a question mark? In Spanish, it's great because the question mark comes right at the beginning, so you know that a question is coming. But this, we have to wait till the end. But we know a good word that we have a research question is does, or do, or is. And we'll have to think about this when we start thinking about what are research questions, because one of the main objectives of this course is helping you identify what is the appropriate statistical test to run for a given research question. And we have to know what's a research question and what's not. Now, when we start to see research questions, I'm going to ask you the same questions again and again. How many variables do you have? And what types of variables are they? This is going to go back to one of our earliest conversations between binary, ordinal and nominal, categorical, discrete, and continuous. And we're going to have to look at data and think about how many variables do we have? What information do we have on each element of our sample? And then what do we need? What variables do we need here to answer this research question? So think about this for a second. How many variables are there? Does the average student at Tufts Medical have an IQ different from 100? Well, you could say, well, they're students. That's a variable. No, it's not. They're all students. So that's not a variable. It's the same. Well, Tufts, that's a variable. It could be Harvard or somewhere else. Well, no, these are all Tufts students. The only variable here, there's only one, and it's IQ. And what type of variable is it? I mean, this is just probably a really long discussion, but we could get into it. But let's treat it as continuous for now. Let's treat it as we could say that it makes sense to talk about the mean IQ for a sample. And we can say, let's say that we can write a null hypothesis here that says the average IQ is equal to 100. And then the alternative hypothesis would be simply not the null, right? So if the average is if the null is it's equal to 100, the alternative would simply be not the null. So we set up these tests, hypothesis testing. We need to state these hypotheses. So you go out and you collect some data. So let's say we take a random sample of 25 medical students. We calculate their X bar, 105.5. Ooh, higher than the null hypothesis, right? This is interesting. So you start to think about, could this be statistically significant or not? Now, you can't write a letter to the New England Journal of Medicine and say, hey, look, my mean is 105.5. It's higher than the null hypothesis. Because it's possible you got 105.5 by chance alone. Is 105.5 different than 100? Yeah, I mean, my kids would say, yeah, it's different. It's bigger. But now the word difference and bigger, they mean different things to you. Because you have to ask, is it statistically significant? Is it a significant difference? And the only way we can do that is by running this test. Calculate the standard deviation or the spread, and using the sample size and the standard deviation, I can plug in my SEM, right? The denominator of the t statistic. The numerator of that t statistic is sort of what is that signal? How different is my observed mean from the hypothesized mean? It's 5.5. And I get a t statistic of 1.56. So again, calculate t, and then you got to convert it into p, into that currency. Now, I don't think any of you have had the time or the energy, not really autodidacts in the way that you would sit around and memorize your t tables or your t distributions, but take a guess. What do you think that p-value is going to be for 1.56? Well, remember, a p-value is the probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. If the null is true, what do we expect to get for t? Well, we expect to get something around 0. Sometimes a little bit higher, sometimes a little lower. What quantifies how much higher and how much lower? The SEM. 68% of the time, we'll get a t in between -1 and +1. 95% of the time, we'll get a t in between -2 and +2. Now, where's 1.56? How does 1.56 look? Is it weird? Is it impressive? Well, all that a p-value really is drawing. It's coloring, right? All we got to do is look at what would I expect to get if the null was true, and then it's say my results really are just a random. I just grab like a claw machine, a random thing of those potential results. So I can draw out what would I expect to get if the null is true. I would expect to get t around 0. Sometimes a little bit higher, sometimes a little bit lower. And look at this. I'm going to go right to 1.56, and I'm going to color that in. The probability, remember, the probability, you're reaching into this potential realm of results and you're just grabbing one randomly. That's what this is. The histogram can be thought of in terms of probability of grabbing those results if the null is true. Results at or more extreme than your value. So you go to 1.56 here, and you go to -1.56 here. And then it's just the area under the curve. That's your probability. Just color it in. Now, then you need to ask yourself, well, what percent of the curve is colored in? And specifically, how much of it relative to alpha? Did I color in less than 5% of the curve? If so, statistically significant. If alpha is 0.05. Did I color in more than 5%? Then it's not statistically significant. So take a guess. How much of that's colored in red? We can have Stata calculated for us exactly. The code is t-test IQ equals 100. Where did the 100 come from? Well, that's our test. Here's all the mean, the standard deviation, the standard error, and so on. And there's our p-value, 13%. That's how much of the curve is colored in. Statistically significant? No. So here's one sort of, if you had to explain to your mom or to your roommate, what is a p-value? We would say, if tough students really had a mean IQ of 100, we would get results like this 13% of the time. The like this is the t, right? The statistic that summarizes our data. And that's not that weird. It's not enough evidence to reject the null. I have a German word on here that means watch out or be careful. It's not equivalent to accepting the null. Accepting the null would be tough students have an IQ of 100. And obviously that would be pretty dumb because we just got the X bar was 105.5. So why would you conclude that is 100? If you're going to conclude anything, you would say 105.5. But the statistical test allows us to say, what's the probability of getting our data if the null is true? Now here we say, well, we have no evidence to reject the null. Not enough evidence to reject the null. And how do we summarize that? Remember, we talked about some of these important elements that you need to include when you summarize your data. Here are a few different ways you can summarize it. I'm going to read through these. We do not have enough evidence to conclude that the average Tufts Medical student has an IQ different than the US average, which is 100, right? So here we see 105 versus 100, and I state the p-value. Now, eventually, when you read things like this, it'll be obvious to you, oh, that's a one-sample t-test. But when you're learning this, I want you to say, if there's a p-value, there's a test that you ran, say the name of the test. Now, the other thing we can do is we can look at the confidence interval. And from that Stata output, or you can even do it for hand, you can calculate this CI using 105.5, the multiplier, and the standard error. And you can say, we're 95% confident that the mean IQ of all Tufts Medical students, remember, we just had a sample of 25, is somewhere between this and this. Now, what's really interesting about that is our null value is 100, and it's in there. It's in there. So just by looking at that, you know that the p-value is going to be greater than 0.05. The confidence interval and the p-value will tell the same thing when it comes to statistical significance. Another way you can write it is just say Tufts Med students have an IQ of 105, which is not significantly different than the 100. And again, I give the name of the test, and I give my p-value. when you practice, when you do this, get in the habit of trying to summarize things different ways and make sure that all the elements are in there. Run it by somebody else, me, the TA, a classmate, and make sure that your comprehension, interpretation, and understanding of these isn't just a plug and chug. It's not a mathematical sort of thing, but they truly understand what the t-test does in terms of testing your mean relative to a hypothesis about the population mean. We're going to build off of this in 2 sample t-tests. So it's really important that you understand the mechanics of this test now. All right, see you soon.